Hey, Nathan Kapitaniuk here from Northern France. I'd like to talk to you about nuclear fusion. It's actually happening on the sun right now. It's what gives us the sunlight we get every day, which makes life here on Earth possible. We would like to use that fusion to make energy clean and healthy and solve the world's problem. So what is the world's problem? It's how we make electricity today. It's estimated that by 2050, we will be 9 billion people on this planet. That means a need for a great amount of energy. And each person will require 2 to 3 times more energy than the average person does now. So what we need to do is look at the ways we produce energy today and see if they will sustain the generations of tomorrow. The most common way to make electricity is fossil fuels. In the US alone, 70% of the electricity comes from the burning of fossil fuels. But the problem with that is that fossil fuels are not renewable, and we won't be able to burn them forever. It's estimated that petroleum will be gone in 40 years. Then we have nuclear fission, which is responsible for 19% of American electricity. The problem with nuclear fission is that it produces large amounts of nuclear waste, and we haven't found a good way to get rid of it. And then a small percent of US energy comes from what we call renewable energies. The problem with these is that they're very, very costly, and they don't produce enough electricity to fill our needs. So, pretty scary, right? It looks like all the ways that we use to make energy are either very dangerous, with tons of nuclear waste being produced, or don't produce enough, like windmills and solar panels. And then there's some that use fossil fuels, which are slowly disappearing and produce amounts of CO2 that appear to be dangerous for the climate. So this is where nuclear fusion looks incredibly good, because all it needs is water to work, and all it produces, well, is helium. So you may not understand what I'm talking about, so let's show you how this reaction works. I'm not gonna show you one of these boring graphs. So instead, I'd like to show you a story to explain how this reaction works. This is one of the many reactions that can happen with nuclear fusion, but it's one that's very promising. This is the story of a group of friends called tritium. They are composed of 2 neutrons and 1 proton. Then we have a couple called deuterium. They are composed of only 1 neutron and 1 proton. They were walking along in the heat, and they did not want to be bugged. They bumped into each other and got into a heated debate. They kicked out one of the neutrons and became helium. So, did you get it? In case you didn't, I'm going to redo it a second time and do it with the scientific language. So this nuclear fusion is possible because of these 2 isotopes of hydrogen. Tritium with 2 neutrons and 1 proton, and deuterium with only 1 neutron and 1 proton. In a very hot environment, these 2 isotopes are moving very quickly, and thus they can collide when normally they repulse each other, creating a fusion which produces a lot of heat and repulses 1 neutron, thus giving us helium. So do you see why nuclear fusion could be so incredibly useful? When the 2 isotopes of hydrogen meet and bond, they produce a lot of heat. The same heat that is needed when we burn fossil fuels, which eventually is turned into vapor, which produces electricity. So in a few years, we could probably replace all these fossil fuels by nuclear fusion. The one glitch, however, is that we have not been able to start a nuclear fusion without putting more energy into it than we get out of it. So that is why we are still not using nuclear fusion today. But don't worry, the future of nuclear fusion looks incredibly promising, with companies across the world working on it day in and day out, such as my beloved countrymen, the French, with their tokamak, which has these magnetic walls that can withhold plasma which is heated up to 150 million degrees Celsius, thus allowing nuclear fusion to happen and creating a lot of heat which would create electricity. But this topic is for another time in another video. So, I hope you enjoyed watching and that you're as excited as I am now about the promise that nuclear fusion holds for the future. Thanks for watching.
Bye.